Okay, so now we will continue the induction motor with the 3.6 subtopic. This is the starting induction motor. So we can actually directly connect the induction motor by connecting them to the power line. Okay, however, they may cause the voltage dip. Okay, so suddenly the voltage will drop. I can say will drop. Okay. However, for one rotor induction, okay, for one rotor induction motor, so to solve the problem or to overcome, so they can insert the extra resistance increases. We can put the extra resistance, okay, so they will increase the starting torque and also reduces the starting current. So we need to know when the starting current is too high, so the motor will overheat and also can blow. Okay. For squirrel cage induction motor, the starting current is depending on the rated power. So the rated power. So rated power is the power consumed by the load. Okay, and also the rated voltage. Okay. So since this is a rated voltage and also current, so the equation is S equal to VI. Okay, so voltage and ampere, so kilowatt ampere. Okay, so this is not a slip, but this is the apparent power. Okay, or the rated power. So the S at start, or the apparent power at start, okay, is equal to the rated horsepower times with the caught later factor. Okay, so at the next slide we will see the caught factor. Okay, so since this is the S, so we will look at the S and then we can find the value of I. Okay, so at this point the I is the line current. Okay, so this is the start minus divided by 3. So since the voltage is the phase, okay, so we can write the line voltage. Okay, so we need to convert. Okay, so this is I can say the voltage. However, the correct actually is like this. Okay, 3. Okay, so this is the correct one. Okay, I line. Okay, so this is the equation. Okay, so the caught later factor in apparent power, which is in the kilowatt ampere, kilovolt ampere per horsepower is given on the nameplate. So when you buy induction motor, so normally they will write the nominal code later for your motor. For example, if your motor is they write C code, so it means that the log rotor kilovolt ampere per horsepower is in between 3.55 until 4. Okay, so normally during the calculation we will take the maximum. So we will take the maximum to calculate. Okay, for more understanding we will do the example. So for example, 480 volt 50 horsepower induction motor has start code H. Okay, the code is H. So find the maximum current that may be expected at starting. So since they give a H code, so we look at the H. Okay, so the maximum is 7.1. Okay, so the code is equal to 7.1 kilovolt ampere per horsepower. Okay, so we need to find the start as start. Okay, is equivalent to the horsepower. Okay, HP times the code. Okay, so for here is 50 times with the 7.1 kilovolt ampere per horsepower. Okay, so try to calculate 50 times 7.1 kilo. Okay, So what we get here is this one is equivalent to 355 times 10 power of 3 watt volt ampere or 355 kilo volt ampere. Okay, so to find the I, so IL is equal to S start divided by root of 3 times with the V. So this is the phase V line. So V line. Okay, so 355 divided by 3 times with the 480. Okay, from here we can get power of 3 by the 480, so 426.998. okay, is equivalent to 427 ampere. Okay, so 427 ampere is very high. Okay, so we need to make sure that the current flow at the starting is at the minimum, or at the not the minimum, at the required only. Okay, not boost to highest point. Okay, in order not to allow the current to flow very high at the starting, so the starting circuit is used to reduce the starting current. However, it also reduces the starting torque. Okay, as long as the motor is moving at the starting, then it's okay. So then there's a safety issue. Okay, the common approach is to reduce the motor terminal voltage. Okay, they control the voltage to reduce the motor terminal voltage. Okay, so during the starting by using the auto transformer. Okay, so the transformer will automatically convert from if the current is too high at the starting, and then they will reduce, and after that they will change again to the normal condition, or the rated value. So for example, like this. So you can see this is the three phase power, 1, 2, 3, and this is also the output. So this is input from the line, so line 1, 2, 3, and this is the output. So at this point is the auto transformer. Okay, so at the starting, so you can see here they will close the first switch. Okay, and then the current will start to flow. Okay, so from here they will reduce the flow from the line, and then convert because this is a transformer, so we reduce, or the step down the voltage, also we reduce the line current. Okay, so after that, so they will open again. Okay, it's like they open the button and close to the next section over here. Okay, and then the current will flow 100%. Okay, the current will flow directly, no other transformer. Okay, so therefore after the starting, so they will operate as usual. Okay.